Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to work on KanoScript. Okay, so off stream I did actually work on something. That's gonna go up on the YouTube channel. I just did it offline. It was very quick. Basically, now we can reassign variables. Yeah, so you can declare them and then reassign them. Yeah, and I can just show that this works. So if I go ahead and build it, actually no, I need to build it first. Okay, and then I can assemble it, and then I can actually emulate it. Echo that 15. There we go. So you can see it did actually reassign. So basically the way it works is it just uses index swap, which will swap the element on top of the stack with the element at the index given. And then we just pop off the unwanted one, the old value, right? So today I would like to I'd like to be able to have if statements, right? So the work in progress way it is gonna be something like this. So if foo equals 15, then that, and then there will be an end block. And that's sort of how you know the scope. So I may change this end then, because I'm not a big fan of it. Like the end is fine. So but the end we use to end any kind of scope. But I'm not so sure about this, you know? I'll think about it though. For now I'm just gonna do that, and then it'll be trivial to change in the future. And obviously we'll have stuff in here. So to do this, we need a way to compare, right? So let's do that first. Let's set int equals 12 equals 12, right? And this is just going to compare. So it's just going to be evaluating the expression. It's basically just another operator added. So we can do that. It shouldn't be too hard. Okay, so let's just go through anywhere that we have operators, right? So we need tt double equal. So we'll need to actually update the lex search so that we can actually lex that. Okay, and then we have a few other places where we are going to need to update. Yeah, so we need opw double equal. OP equal. Well, really it needs to be OP equal in this case because the other one is not an operator in the same way. And then I'll do the greater than and stuff after. I just want to get this one working first. So, and it's going to be just an expression, you know, just another part of the expression. Okay, that might have been it. Yeah, here's the reassign, variable reassign. So we have that. Okay, so I suppose that was it. This extra. Okay. Let's see. So we need to is operator. We're gonna need to do something else here for this. We're gonna need the next character, right? Show. How do I want to do that? Create operator tokens. We pass a single character in, and that's not gonna work in this case, right? We're gonna need to look at the next character. So how do I want to do that? Well, I could handle it differently, right? So if it's equal, right? Where's the equal? Right here. So then we just need to look at the next one. So then if u.len is greater than 1 and u.data 1 equals that as well. So that means they're both equal. So then it's a double equal token. So we need to actually create that token. So actually we can still use the same thing, right? Let's define the token thing. Token equals 0. And then we can set token like this. And this will be in the else. Okay, there we go. It's a little bit messed up. So else the token equals create operator token row u.data let it start and the u.data. So that'll be fine. Because we're only going to call this when we encounter two of them. So we only need to pass a single character in this case. But actually maybe I should make it. Maybe I shouldn't do that because when we have the other ones like this, it's going to be harder to know, like differentiating these two inside. So I'm going to actually update this so that we can actually pass the, probably the whole view in there. Let's see. I need to think. Is operator, right? So we have that. Let's just pass the whole string. The whole string view, right? And then we will create it and we'll pass the whole string view in here as well. And that'll probably be even better, right? So then we don't need this at all. Don't need this whole else and everything. Token like that. Yeah. So let's update these. So let's go to is operator. Oops, I cannot spell. Is operator. So it's going to take a string view now. String view. So let's do switch over data. And then these ones will still work all the same. But then for this one, in the default case, then we'll handle the rest of them. So if len is greater than 1, and well, actually let's do case equal, and then we can handle it in here, right? So this can still be return false. This will be return true if they are both, right? So if the following one is as well. Len is greater than 1, and data, no, data 1 equals equal as well. So if they're both equal, then we'll return true. Like next, do something like that. There we go. Return true. So that should be double equal. And then we need to handle it in here as well. It's just the same way. We need to update the character to be a string view. So I'm gonna actually change that to S probably. No, I'll change it to be like how that is. View, and then switch over view.data. And we can just handle it the same way, right? Okay, case equal here that. Then token.type equals token.type equals pt double. Okay. Yeah, something like that. Okay. TD double equal is not handled on switch. Okay, we can handle that pretty easily. We'll just add it here. Double equal. Okay. The statement may fall through. Okay. Yeah, I forgot the break. Actually, we want it to fall through though. Hey, Outlands, how you doing? Okay, 333 falls through as well. I want to break it. Okay, so that compiles then. Alright, so let's see if it actually can parse it properly. So, or Lexit rather. So let's print token array and build that and try to compile it. Whoops, and okay, so we do have the double equal. Then we have an equal as well. So I know what happened actually. We need to consume 2. Yeah. Okay. I didn't think about that. We need to actually consume the tokens. So, yeah, we can do that, let's go to the lights. Let's look at that. Is operator, then we create it. So, should pass as a pointer. Let's do that. So create operator token. So it has to be a pointer now, so we need to keep that in mind. Because then we can actually, we can modify the size, or the count, and the length, and the data. So we'll switch over that. So we can like double the graphic, that's right. No, we need to do view arrow data. That would, there we go. Okay. View arrow len 1 and view arrow data is that. Then we want to just we want to chop left. So view equals view equals view chop left. And yeah, so that will chop it. We can still return token and all that stuff. So that should actually fix that. Are you using C on your main job? I do not have a job right now. I'm in school currently. So no. No, I'm not. That did actually fix this. That's good. Yeah, I've not had a programming job yet. Okay. So we have equals that. So that is correct. So we should be able to now. This should work. Yo, what's up? How you doing? That's an interesting name you got there. Okay. Should be able to parse it then. So let's go to parse. Parse right here. So case of, yeah, basically it's just in the parsing expressions, right? So parse expression. So what's going to change? Basically it's just the operator is different. Minimum 10, okay. Yes, that's not different. Create operator. Yeah, so we need to actually set the precedence, right? So let's go to precedence. OP get precedence. Yeah. So we need so what is the precedence of equal equal act? I don't know what it is. I'm not sure exactly. Okay, let me try like this. So Python. Oops, Python. Right, so we can do that. 15 times 2 equals 30. True. Okay, so the time is evaluated first. 15 times 2 equals 30. And that is not. Okay, so I guess it is 1. I'm just going to assume that, and I can change it later. Okay. And I'm pretty sure that is... We need to add it here, actually, as well. Equal. We got type equals OP equal. And actually, this can go down here, because I think that makes sense. What's the goal for Kano script? Like creating language for implementing features for Kano editor. Yeah, that is it exactly. So, yeah, basically my text editor, which I'm using right now, doesn't really have a way to, configure stuff, write plugins, things like that. Like with NeoVim, you have Lua, right? And with regular Vim, you have Vim script, that kind of thing. So I'm wanting something like that for mine. And I considered using Lua or an already existing one, but then I thought it'd be more fun to make my own. So that is what I'm doing. Yeah. So that is it's for creating features. I'm probably gonna build features, like a lot of the new features, built on top of this as well, instead of writing it in C. Things like that. All right, and I think that's pretty much it. Alright, so it did compile, but it did not actually compile properly, because we do not handle, actually, OP types, let's go to that. Div, and then compare equal is the double equal one. Making a whole program from screen language is a big task, but nice to finally talk. Okay, well, I'm glad that I'm your favorite. That's very cool. Oh yeah, it is a big task. I do realize that. But that's, what's fun about it. So it can go on for many months. Very equal. Okay, looks like that worked. Yeah. So basically what this will do is we'll pop the top 2 values off the stack and then see if they're equal. Good luck. Thank you. Thank you. I appreciate that. Yeah, so I think that this works now. So if I actually run it, so if I exit, it's going to exit with 1. So build test, echo that 1, and that is correct. Okay, so we have double equal just as an operator, with a precedence of 1. So it's the same as that. So basically, this will be evaluated entirely, and so the left-hand side will as well. Well, no, actually, it doesn't get evaluated first. So actually, the precedence needs to be a special precedence. I didn't think about that. Basically, it needs to look like this instead. Yeah, I forgot about that. Basically, we evaluate this side and that side. So I'm not going to worry about that for now, but I need to think about that. So it needs to have a different level of precedence. Yeah. Well, this will work for now. So we can compare equal. Yeah, so I'm going to implement the if, and then I will think about the precedence after that's done. So if, it's going to look like this, right? If, well, let's do this. set it equal to 12. If foo equals 12, then so we'll do this. So this is going to compile into something like this. So we have this. So this is the compare equal. So imagine this is the if statement, right? Compare equal. Then we would do 0 jump. So if it is 0, which means false, we'll jump to the end, right? So we'll just create a label here, end. So this is a label. So we'll jump to it if it's false, or if it's true, we'll continue down here and we'll do the other stuff that is in here with it. So it looks something like that. So in this case, it is equal, so it will not jump. So it will push 1, 2, 3, and then print it out. So we can actually make sure that that works. And I actually seem to have messed it up. I found push. What? Might be jump 0 actually. Let me see. I could actually create it. Put a new window here, and let's look at. Let's see. So jump 0 jump. Yeah, it is 0 jump, which is what I have here. Yeah, the error messages are not very good. Is this label wrong? End shouldn't be. Oh yeah, 0 jump end. We have to provide that. I forgot. Yeah, you have to provide the label. So end. So we use like a number here. Like that. I'm pretty sure we support that. I hope we do, because otherwise it's gonna be a lot harder. Build / tired. Okay, and it looks like we did. The stack did underflow because we did consume this stuff, but you can see it did do that. And then if it's false, I won't underflow. I don't think. It won't underflow. Yeah. So if we make it false, so if we change this to 13, right? Then it will just skip over this and it will exit. Okay, I guess it did not make it to the exit for some reason. I don't know why, but it didn't print out 1, 2, 3 as you can see. So it did actually work as expected. Yeah, I'd have to go through and figure out why it's stacked on the float, but I'm pretty sure it's fine, right? Hopefully. Alright, so let's exit there. And basically, oh shoot, does it consume the 0? Yeah, so I guess the jump does consume it. So we need to keep that in mind. So what we need to do, basically, is there's a few things. So first of all, we'll do the lexing, right? So we need not let, but we need if and then and end. So there's gonna be a few new ones. So let's put them here. TT if, TT then, TT end. So some new labels here, and they'll all go at the end of these. If, then, end. We'll just that. Okay, so it looks a little nice. So we have those. So we should be able to add those. Add those here. So that's gonna be in the get token type. Yeah, right here. So else if. Why do I not pass it as a string? I don't know. I should probably do that. Stir with if. Stir size equals 0. Then return TT if. Then we have else if. Stir then stir size equals 0. Then return that one. Else if stir compare stir end stir size equals 0. Alright, so the then and end are basically the equivalent of brackets, you know. Basically is what they are. So we'll treat it like that. So it's like the begin and end of a scope, right? Alright, so that should be it for the lexing actually. So I should be able to print it out now. So we go here and return 0. We print token array. I'm gonna actually just comment that out now so that I can easily handle that. So we don't handle that in the parse, but that's okay. Ano and if identifier equals integer, then that. So this is basically an expression here that we're going to parse. Then do this and end. Okay, so we do have all the stuff. So let me actually add something in. So we'll exit with 15, right? Otherwise we'll exit with 12. Do that so I remember. Yes, in that case. Okay, so let's try to do that. It looks like it worked. So equals integer, then exit integer, and okay. So that should work. So now we need to actually properly parse this. So actually get rid of this, and I will comment this out. Parse, okay. Parse that. Okay. So in here we need case of if, and then we're gonna generate all the stuff from that. Case tt if. Let's actually add these. Great. Okay. So what we need is the token. Well, we need to add all the node types actually. Getting a little bit ahead. So let's see. That's the expert types. We don't need to do anything with that. Var type. We don't need that. Arg. Basically, yeah. So node type. So we need type if. This will be an if statement, and it's going to contain all of the information on it. And we'll have probably a type end as well. So we need an if, then, which basically where we just update the stack, you know. So or the not the stack, but the labels. We set the labels. So let's add all of those. If, then, and they'll all be handled separately. So these two do not need any value. But if does need a value, so it needs the expression value. So I think we can actually just use that from there. So where do we have node value? Right here. So we can use the expert as the value. Because that's all that we need, right? Because that's basically what it is. What it is an expression. So we'll create the node. Node 0. So we're gonna set the dot type equals. Type equals what is the type? Yeah, it was type, which I'm gonna change this to be node instead of type as the prefix, but I've not done that. Type if, so that is that, and then the value, we need to parse the expression, but first we need to, do we have to consume this token? I think so. So let's do token consume. And then we will call parse expression. So node.value.var, not var, but expert.value. Is that right? Equals parse expert tokens. Okay. And that should be it. So then we can va append root node. So the if should work. Parse expert from expert pointer. Parse expert is an expert value. Don't know what that means exactly. Is it just .expert? No. Type expert from that. Okay. Let's see. Let me look at the node values. Because it does not seem right. So we have that. And we have the variable. And that has the expert. Do we need this other data with it? Any other data? I don't think so. So I think we'll probably make a new one. This expert should be a pointer. Yeah. Let's do this now. Okay, so that should be okay. I need to rename this stuff. I call it if. And what else could I call it? Condition. Yeah, because all the conditions are going to have that. So, okay, so all the conditions. And then TT then not handled switch. That's okay. 6 we can fix that pretty easily. So we're going to actually handle it soon. So TT then break. And I'll just copy this for TT N. So these are going to be pretty simple actually, but for now I'm just going to assert false. Assert false. Not implemented yet. And the same thing here. Alright, so let's go back and we'll run it yet again. Assertion failed. There we go. So I suppose we did make it to the bin. So hopefully this worked. Let's try to implement these. So now we're gonna do some stuff with the state. So let's go to the program state. Program state. Oh shoot, we don't have the program state in the parsing. So how do I want to do that? Because I need to keep track of the current label. Like we're gonna need two things. We're gonna need the current label and then the label stack, right? And we're gonna pop from the label stack as we go along. Push and pop. And we need it when we're generating. So, well, we can just set the label. So we can just have it in here, right? We'll have the current label. And then we'll have the current label, but we don't want to decrement it. So the label stack, it's going to basically contain just the current label, right? So label stack equals 0 times t. Let's even make it. If we make it a dynamic array. Yeah, I suppose so. So let's just find it right here, and then I'll move it up with the other structs later. So this will be label stack. So it will have some data count and size the capacity, and then we can just easily append it. So let's define a label stack here. Labels. Okay. And we'll zero initialize the whole thing. And we'll just basically push the current label onto it and increment the current label. So what we can do here is append. So then, yeah, so we need this to be the same though. Yeah, so this one pushes and the other one pops. So this one is pushing. The other one we will decrement the count and take the top stack. So what we need is append it to labels. Labels. We want to append the current label. Current label plus plus. So we want to increment. And that's pretty much it for this. But then this one we have to set we need to create the node, right? So node equals. So we do need values in there. I forgot about that. Equals type then. And then this one is type n. And what the value that we're going to store here is, for this one, we're going to store the current label. So node dot value dot label, I suppose. Whoops, label equals current label. And that's just going to be the number, right? And then we increment it. And here we want to set the node dot value dot label equals, we don't want to decrement the current label. We want to take the top of the label stack, labels dot count minus, we need the minus first actually. Minus labels dot count. And that's it, right? So just take the top of the stack and decrement. And I think that is pretty much it. So we need to actually add this node value. So label is label. Just a size type. Okay. Node set not used. We need to actually append them. I forgot about that. So parse. We can append them pretty easily. It's like this. And there we go. Build that. This needs to be labels.data actually. That is quite important. Okay, so we should be able to run it now. It gets stuck in an infinite loop, it seems. Let's actually return there. So it might be an issue with parsing. And let's try to, well, we can't really, let's see if that still gets stuck. Okay, it does get stuck. That's interesting. So what is causing it to get stuck? Did I forget to do something in the parsing? Alright, maybe we could run GDB. And we'll just break on parts. Okay, we'll run in Pano, and then we'll just step through and see where it gets stuck in it. Alright, so this is the item. So I don't think it's here. I think it is. Could be in there. It seems to not be. Then. Okay, so we have to do that. And we don't. Okay, so it doesn't continue. It just keeps doing that over and over again. Okay, that is interesting. So what would cause that? Okay, so it looks like we need to consume the token, right? That is what the issue is. So, alright, so we token consume in there, but we need to do that in here as well. And in here. Okay, so I think that is what the issue was. If we try to run it now, it does not get stuck. So let's try to actually print every single one of these elements. Root.count, and let's just print the type, right? Like that. Root.data I.type. We need to actually write that in node types like this. Running kind of stream, glad to have you. How you doing? Glad you are here. It's been a while, yeah. Been a while. Native var deck, if then, native, and it ends. So why does it end? We should have another end in there, but we do not, for some reason. Yeah, we have the last native though, but we don't have the end. Types. Are those messed up? Did I not include the end? I do have the end in here. Type end. Did I not set it right? Type end. Okay, let's run GDB perhaps. Let's see. Error rack follow. I apologize if I messed that up, but that's what it looks like to me. Error rack. Thank you. And let's break on. Let's just break on parts and we'll step through it. So let's run internet game. And let's see what happens. So, yes. And let's see. The notification seems to not come on, which is interesting because usually there's like a pop-up when somebody follows. I don't know why it did not. Okay, so this is the right. Then. Then we have the if, and then we'll go to the then. Then we should go to the exit. Let's print tokens. And there is two more. And let's see. So then we just go to the next exit. Why did we do that? Did we consume too many? Too many tokens? We could have done that. I don't know how that would happen though. Alright. QML time at work. What is QML? I believe I looked this up before. Programming. Okay. Work is dynamic, 1 week. React, 1 making UIs, and Qt. Oh, okay. Oh, it's for Qt, I see. Yeah. Very cool. Not the React part. Not a fan of React, but can you explain what you're doing for 5 years old? Sure. In a moment I will. Data 0, 1. So it is a TD none. Why is that? Okay, so that was kind of interesting. I'll explain what's going on. So basically, I'm building a programming language, like any other programming language you might be familiar with, C, Python, something like that. So it looks like this. So here is write. So this basically outputs a string to the console. So when you run it, it will say hello world. This declares a variable which stores a value. Basically that. And then this is an if statement, right? So you're checking if the value of it is equal to a value, and then we'll do something. Otherwise, we'll just skip over it. So what I'm doing is implementing the if statement right now. Basically, I'm building out the nodes for the parsing, right? So it returns a series of nodes, which then you iterate through, and you basically create code out of that. Lower level code. So it compiles to a special kind of code that I actually made. So this is the assembly for it. It's not native assembly, like you would be familiar with like NASM or whatever. But it compiles into a special bytecode, which gets interpreted. Which that might be kind of confusing. But I don't really know how to explain it quickly. But basically that's how that works. You don't have to worry about that back part though. Okay. Yeah, so why does it do that? We can print the tree and it works, right? Or print the token array, rather. And we have an end token. So for some reason we consume it. So the exit must consume too many tokens. That would make sense. Not this one. No, TTX. Yeah, so right here. So do we need this? Okay, because then we get the end. So I don't know why I would need that. Because that was consuming an extra token, which we do not want, obviously. So and native. Alright, so now it actually, we are parsing it correctly, it seems. So we should be able to generate the code for it now. So in here, we need to basically have cases for a few of the different types of nodes. So we'll have case type if, and we'll do so. Case type then, and we'll also do so. And finally for type n. Okay. Actually, I guess I could have just done the stack for this part, because we don't really need it in there, but it doesn't matter too much. Like the stack for keeping track of the labels, basically, is what I mean. So I just assert false for this. Yeah. Okay. Not implemented yet on 840, so that is the if. That is correct. Okay. So basically, we need to compile the expression, and then pass. Then we need to do zero jump, right? So we need to compile extra state file and node value dot condition. So that is the condition that we're compiling. Let's also print the header for it, right? So we have two of them actually. We have expr, and then we have if statement. So that's like the global one, and it's the sub one. So we compile the expression. And then we need to, we'll do conditional jump. So let's do this. Then compare equal. State file, and that is it. So let's go to our other gen. So we have a bunch of functions here which generate the code, and it also keeps track of the stack size. Program state file on a stop. So this is going to just do compare equal, and that's it. No, that's not what I want. I don't want compare equal. I want zero jump. That is what I meant. Zero jump. Zero jump to a label. So we need a string view label. Yeah. Okay, so we need also, instead of this, we want to put view print as UARG label. Okay, something like that. Zero jump. And that is going to, that's going to pop one off the stack, if I'm not mistaken. I can check as well. So we can open this, and we can do zero jump. And it does pop, and it doesn't have a pushback or anything. So it does pop the stack. So we need to decrement it by one. So we can do state stack size minus. Okay, so let's go to gen. This needs to be zero jump. State file, and then we need the label, which is going to be a string view, but we have to actually create it. We'll pass the label number instead, which is in the if. No, we don't do this till the then. Or do we do it on the if? Actually, yeah, I think we want to do it on the then. So that's actually it for the if. Then if is always followed by that. So we can do this. And we need no value dot label. And that's going to be it's not going to be the right value. Because we're expecting a string view, but that is an integer. So we need to deal with that. Is there anything else that we need here though? So we append the variables. I don't think we need anything else. So if, and then we generate the zero jump. So let's do that. Let me revise this as well. So we want a size tag, right? Size t. And we can change this. to be instead, so this is just label number, right? And label. Okay, and that should be containing the right labels. So then we need to handle just the type A, and that is right here. Okay, so we need to generate a label. Then label state file node value dot label. We generate that. So it's going to be similar to this function, but it will generate a label instead, which does not modify the stack anyway, so we don't actually need to state it. It just creates a label that followed by a colon, and that's it. So I think that'll work. So let's see, so gen label, when we call that, we don't want that's this. And let's see compiler errors. Gen label does not exist. What? There we go. Okay, it just didn't save file. So let's try to run it on Arcano. And it looks like it compiled. We can look at the assembly. And we have label 0, 0 jump label 0, so the labels are right. We have push 15 and exit 60 there. So I think this will actually work. Yeah, it looks like it's actually good. So if I try to assemble this, and then I try to run it, okay, and it exited with 15. Okay. If I change this, so if we check if foo equals 13, it should exit with 12. So let's recompile it, reassemble it, and interpret it, and let's look at the exit code. 12. Okay, so it actually worked. That's pretty cool. That's pretty cool. So you can also write in here. So write foo is 13 with a new line, and then at the end we just write foo is not. So like we can't do anything special like print out kind of thing, but that's okay. If it's not, or foo is. So then we can build it again, and it's gonna actually write that instead of being an exit code. Foo is not 13, and if we modify it yet again and change foo to be 13, then these can be 13. Okay. It prints them both though. Yeah, we don't have else. I forgot about that. That makes sense actually. Yeah. It just goes to the end there. That is fine. So let's try a nested one. So if foo equals if 13 equals 13. Let's do that. Then I just want to see if this works. So right, 13 is 13. And I want to see if that will work. Let me look at the generated assembly. So it does look like the labels are right. That is good. So we can try to assemble this now. And 13 is 13, and if we change it so that 13 equals 14, and then we try it one more time. Okay, yeah, so it looks like it works, nested ones, all that stuff. That is pretty cool, and it did not even take that long. Okay, yeah, so let's get rid of this. Equals 13, 15, it's a bit simpler. Okay, so I will actually commit this. Okay, that was actually pretty big. Alright, let's see, so what else? We can implement the rest of the comparison operators, right? I think that would be a good idea. So we have double equal. We have TT equal, right? Let me think. So we have equal, not equal. Let's do that one. We have not equal. Greater equal, greater than or equal to, less than or equal to. We also need greater and less. So TT greater, well, not over there. So greater and TT less. So like this is just less, and this one is less than equal. Okay, so I think that is good then. So we need to add all of these here as well. After the equal, the not equal, and then greater than equal, less than equal, greater than, and less than. Okay, there we go. So that should be all of those, and then we can handle them in here as well. So I do need to do some stuff with the precedence because it's not going to work quite as expected. Yeah, because like if we do something like 15 times 3 equals equals 15 plus 15, it's not going to work because it's going to think that it's going to evaluate this 30, and then it's going to compare it equal to 15, which obviously is not right. So we need to evaluate, we need to change the precedent. So I will get to that. That'll probably be something to do either off stream or like for a separate stream. Probably not today. Okay. So type that. Yeah, we don't need that. I think that is all that we need there. So now we need to modify the actual functions. So yes. So if it is equal, so that's the one that will start with equal. So case that. Like this. And then we'll have another one for greater than or less than. So either way, this one is going to return true. So we don't actually need this check. So these can actually go up here. We need that when we're actually generating it, but not when we're checking it. Because those are always here, whether they're followed by an equal or not. But this one, these two are different. Okay, then we have the actual generation of it. So equal, then we'll have not equal. Start with bang, right? We'll do this same thing. We'll set it to not equal. Okay. In case greater. If that. Otherwise. Else we can just set it to the regular, right? The regular greater. And this one is TT greater equal. Okay, and then we have the same thing. This is a lot of repetition here, but break still. Okay, and this one is less than. Less than, equal, or just less. Okay, and that should be it for those. So that is all of them, I believe. So, I don't think we have to do anything in the parsing. Let's see, generate expert. Or no, it's parse expert. Operator, so we create operator. Actually, we might have to do something like that. Yeah, create operator. So we have to do that. HTTP not equal. Not equal. Type equals. Yeah, not equal. Break. Or copy this for the rest. So it's going to be greater equal, less than equal, greater, and less. Less. 6 greater. Oops. Greater. And this one is less than equal. Less than equal, and this one greater than equal. Greater equal. Okay. And greater equal. Okay. And that is all of those. So then we just need in the actual compiling. Then it's compile expert, I think that's called it. Yeah, we just need to add it to these, to the type 6. So we have compare equal, then we have compare not equal, we have compare greater than equal, compare less than equal. I think I have all these. And then compare greater and compare less. So I believe that's the right order, hopefully. Let's build that. Alright, so these are not handled. OP less on the player. Yeah, we need to actually define the operators. Operator types. P not equal. OP whoops. P greater equal. OP less equal. Greater and OP less. Okay. So those are not handled in space. That's okay. We can handle that. Getting to be kind of big. t not equal t less than equal t greater and t less. Okay, so that, and hopefully it works out. So let's try to do 2 does not equal 12, then less with 15. So that should work, I believe, hopefully. Assertion failed, unreachable. Okay, 796. Alright, so it actually got here. Interesting. So that's in the parsing. We did not consume it properly. So why did that happen? Create the operator. Huh. Let's print the tokens. I suppose that would probably be a good start to it. Does not equal. So that looks like that worked. So I don't think that's the issue. We might have to step through in GDB. But first, I'm going to take a quick break. I will be right back. About 3 minutes. Yeah, 1 sec. Okay. So, let's see. So, what is the issue here? So it fails. So it is not consuming tokens. So why would that be? Something with the parsing expression. Also, I cannot see what I'm doing. I don't know what caused this. Or what is causing this. So I'll probably have to just reboot. Yeah, it didn't work. So I need to figure that out. Let's see. Parse expo. Token consume. Yeah, OP get right. I think I did not implement that. Yeah, that's what it was. Okay. So TT not equal. TT greater equal. TT less than equal. TT greater. TT less. Okay. That is what the issue was, I believe. So now it should compile actually. Kano.tasm. Yeah, compare not equal. So it should Kano.tasm and then run it. 15. And is that what we were expecting? 15, yes. So it does not equal 12. Yeah, so if it is less than, it's greater than 12 actually. We'll check that. It's greater than 12, then we'll exit with 15. So we'll have it at 13, then we'll set it to 12. For testing, right? So it exits with 12. That's not right. Because it is greater than 12. So what is that? Where's 12? 13. So I must have done it in the wrong order. Because compare, wait, is compare greater? Oh shoot, it takes the top of the stack. Hmm. I need to change that. Let me change it in the virtual machine because it makes more sense to be the other way. Yes, if there's an issue, then just change the machine, right? Okay. How does this work? Man, I wrote this a long time ago. So compare graded. Yeah, what is this? Why do we do this? It's kind of weird, but okay. Why do I do it like that? What the heck? Why don't I just switch over the types? Not sure what that's about, but okay. So compare as type. I don't even pass those in here. Where's that department? Oh, she was probably in team.h. Yeah, okay. So let's just switch into that. Okay. Okay. Hopefully that doesn't like break anything, but I don't think it will. Not SH. I'm just gonna break some of the text because we expect that, but all of them are broken anyway, so yeah, that's a thing. Alright, let's build it now. And let's try it again. So we'll just reassemble it, and then now it is what we would expect. Alright, 15. And then if we change this to 15 to 12, then it's not gonna be great, so it should exit with 12. 12, there we go. Okay, so it looks like that works. That's pretty cool. So we have the not equal, greater than, yeah, they should all work. Okay, what else do we need? So we need else statements, obviously. I don't know that I want to get into that, because I don't have a lot of time left. So let me actually connect it. So implement okay. So yeah. So we have if statements. While loops are also pretty simple. So we'll have like while, which is gonna push a label itself, right? And then the thing is, at the end of a while loop, we need to also put an extra jump. So like at the end. So that's why some probably have like end while as a keyword. But I think we'll be able to just push onto some sort of a stack that will pop from. Like if it's an if statement or a while loop or a function or something like that. So that we will know to create the proper labels, right? Yeah. So I'm not gonna do that now. Again. If so we want if else, of course, obviously. So else, that would require an if as well. Or one of those tags as well. So else would act like in creating a label and all that stuff. Yeah, so we're gonna need a stack where we push the different types. So if if else or if while, we probably need an else there as well, which we will push. And then also when we declare a function. Yeah, so that's pretty cool. But already, like we can do a lot of stuff now. Yeah, once we get while loops, obviously, and functions, we can do a lot more stuff. But yeah, so it is coming along. I guess I might just end it there because I don't have a lot of time left that I can stream. So yeah, I guess next it will be either else statements or else statements, yeah, or while loops. Yeah, I don't know. I'll think about it and see which one I would rather do first. Either way, we're gonna need to do a lot of the same stuff for both of them though. So you know. But yeah, so quickly I'll just show how a while loop would look, and then I'm gonna have to end the stream. So let's see. Here we have zero jump label 0. So we'd also create a label here. So like label, that would probably be label 0 in that case. And this would be label 1, like that. And this is the one that we'll jump back to, right? That we will check. So at the end of it, we will just actually probably jump before this. So actually like that, right? Yeah. And we'll jump to that label. So just unconditionally, we'll jump back to label 0. And that's gonna put stuff on the stack. and then compare them, right? And then we'll execute this jump again. So basically it will just loop over. So it's like an if statement, but it jumps back, you know? It jumps back to the condition. And I think that's pretty much all that we need to implement for while loops to work. Yeah, I believe so. So let's see, other than that, hello, how you doing? How you doing? Ubiquitum, I believe is how that's pronounced. Yeah. So, yeah, I'm not gonna work on it right now because, yeah. I can also look at that in Bing and it looks a bit nicer. Quite a bit nicer, yeah. So that is what it'll look like. I should add some spacing here as well to make it more readable. Yeah, so I believe this will work itself. So, but we don't increment it, right? Yeah, so we would like increment a variable or whatever in a while loop. So the while loop, yeah, we'd probably do something like this. Oops. Okay, now dot, you know, we'd like, say, we would declare x, right, equals 1, and then while x is less than 10, then we would x equals x plus 1, and just basically loop over it, right? So that's kind of like a for loop, but, you know. And I probably won't implement for loops until the future because you can use while loops like for loops. Yeah, like pretty easily. Obviously for loops would be nice to have as well, so I'll do that in the future. But I kind of want to get quite a few features implemented so it becomes usable before I actually worry about extra things that aren't necessary, right? Yeah. So that's gonna be, I guess that's gonna be the end of the stream. So, yeah, that's gonna be it. So thank you for watching, and I'll see you guys next time.